All right, in this question, we are looking at the idea of a common ion and setting up the reaction table for a pH calculation. So in this question, you will not actually solve for the pH. And here we have a weak base, but we could still write the equation here. So we could say, okay, we got ammonia, it's in water, and we are forming NH4 plus and OH minus. Okay, so we're going to gain, we are starting with some of this. We have 0.42 molar, and but we have 0 OH minus. Now, in this case, we do have a common ion. So we have this ammonium bromide, which if we write that out, right, NH4Br breaks up into NH4 plus and Br minus. So we have some of this NH4 in solution, all right. So if this is 0.088, we see it's a 1-to-1, so this is 0.88, and this is 0.088 of ions. So we can add that common ion. Now we don't have any OH, so it's still gonna go this way. So we're gonna have some X's this way, and again, we have 1-to-1 minus X here, and then we're gonna combine these for this part down here. Now, we would use probably the X is small approximation, but we're not given Ka or Kb in this, and not asked to set up that equilibrium expression. And so we just need to set up our ice table. And you know, if this was a weak acid one, we could solve for pH, because that's something we've seen before. With this, it takes a little more conversion with a weak base to get to pH. You can solve for POH and then convert that to pH. Not something we've spent much time on in this class due to time. So let's just set up this ice table. So I'm going to start with 0.42 molar here. Here I have 0.088, and here I have 0. So I'm going to minus X. I'm going to plus X, and then I have 0.42 minus X, 0.0 plus X, and just an X here. So that should be my table. Let's check it out. There we go. So we're just looking at setting up this table, and then with our knowledge of equilibrium and a common ion, you know, this is something with a weak acid that you should be able to solve the pH for.